All right, to start our unit, we're going to talk about perimeter and area, which is section 7.2 of the geometry chapter. The perimeter of an object is basically the distance around the object, whereas opposed to the area is the amount of surface that the object contains. So two different ideas. Perimeter, again, is just the distance around the object, whether it's a triangle or square or rectangle, and area is the amount of surface that all these shapes would contain. In the first example of the PowerPoint, we have, for 7.2, you have a rectangle that's 4 feet by 3 feet. So you're asked to find the perimeter of that rectangle. And you can simply, since opposite sides are equal, there's a shortcut you can do. You can just do perimeter is 2L plus 2W, which is 2 times 4 feet plus 2 times 3 feet, which will give you 8 plus 6, will give you 14 feet, will be the perimeter. And then we'll talk about, well, we could actually talk about the area right now. What would be the area of the rectangle? And I actually didn't do this in example 1, but we could talk about it. But basically the object, if you divided it up into blocks that are 1 foot by 1 foot, it would be 4 blocks by 5 blocks, or 4 squares by 4 squares by 3 squares. And we could simply just go 4 feet times 3 feet, because we would have 4 rows of 3 blocks. So that would give us 12 square feet. So it's just a basic, to count those up, you would multiply. So area in this case is LW. So looking at the key formulas, and these are in your PowerPoint. The area of a rectangle, as we discovered, is LW. The area of a triangle is 1/2 the base times the height. And you can think of a triangle being half of the area of a rectangle that would have that base and height. It kind of makes sense. If you look at the rectangle that's B times H, then that triangle actually has half the area that the rectangle does. And then the circle has the formula pi r squared, where pi is approximately 3.14. I guess I haven't talked much about pi yet, but pi is the ratio between the circumference and the diameter of a circle. And that's a common, most of you, I'm sure, have seen the value 3.1416 or worked it out to different places. That you can go online and find sites that take it out to close to 100 places, maybe more. But anyway, that is the area of a circle. Let's do an example of finding. We did a rectangle. Let's do a triangle. So say my triangle had a height of 5 meters and a base of 4 meters. Well, the area of that would be half the base times the height, because it is a triangle, which would be 1/2 5 times 4, which if you go 5 times 4 is 20, and times it by half, you're going to get 10 square meters is your area of the rectangle, or of the triangle, excuse me. So a triangle, I'll say it again, of height 5, base 4, would have an area of 10 by plugging in 1/2 5 times 4 would give you the area. All right. Well, let's do some applications. Really, the area problems are fairly simple, just plugging in the formulas. If by chance on a web assignment you get an object that's different, what you can do is go to the book, and certainly they should have the formulas. If not, it's pretty standard. You could probably find most objects' areas online if you wanted to Google. And so if I happen to miss a formula, that should be on the, you should be able to research it and find it on the internet. By the way, on the test, I will provide formulas, so that won't be an issue. Okay, suppose you want to install new carpet in one room of your house that is 15 feet by 12 feet. How much square feet of carpet would you need? Well, if you had a room that was 15 feet by 12 feet, the area would be 15 feet times 12 feet, or 180 square feet. So that is the first part of the question. All right, sorry about that pause, but I wanted to make sure. I pulled up my PowerPoint just to make sure all my numbers agreed as I was going through this. So anyway, it is 180 square feet. Now what's going to happen is we're going to kind of continue this problem, and this is identical to the questions in the notes online. But it says, now suppose that the price of a carpet at a store you're buying carpet from is $10.50 per square yard. Roughly how much is it going to cost to put carpet down in the room in example 6? Now the issue we have is it's $10.50 per square yard. And our area, if you recall, was 180 square feet from example 6. So what I'm going to do is convert square feet to square yards. Well, the way you do that is if you think about what a square yard is, 1 yard by 1 yard, then a square foot would look the same, would be the same size, but it would be 3 feet by 3 feet. So if we go 3 feet times 3 feet, that's 9 square feet is my area compared to 1 square yard. So you got to be careful. 1 yard is 3 feet, but 1 square yard is 9 square feet. So I'm going to convert this. So I'll just do a conversion factor times by 1 square yard over 9 square feet, which gives me, if you take 9 into 180, because your feet do cancel, you get 20 square yards. And if we times that by, we can figure out the cost now. We got 20 square yards of carpet that we need to buy, and it's $10.50 per square yard. Again, you can cancel units. You can just multiply too as well, but it will come out to $210 is the cost of the carpet without factoring any labor cost. So again, 1 square yard is 9 square feet. Now I have a slide explaining that, but it's kind of the same diagram, 3 feet by 3 feet. And then we end up with 20 yards squared, and the cost is $210. Okay, kind of staying with just some practical things like thinking in terms of maybe what you might do around your house. What I have in a picture is the floor plans for a house, and what we have to figure out is this first floor of the house, this is the floor plans, what is the square footage? Well, as you can see, it's an odd shape. But what we can do, and there's multiple ways to do this problem. You can divide it up into 2 objects. So like I see how I drew that line. Well, that divides it up into 2 rectangles. And then you could just find the area of the rectangle. Each rectangle, which one, this one's 25 by 25. So 25 times 25 gives you 625 square feet. And then this rectangle is 20 by 15. I'll call this area 1 and this area 2. This area is 300 square feet. So the total area, if we add that up, is 625 plus 300 is 925 feet, square feet. There are other ways to do it. You could do the big square, which is 40 by 250. So 40 times 250 is 1,000. And then you could subtract off this little edge here, little corner, which is 5 by 15 is 75. And then if you do 1,000 minus 75, you get the same answer, 925. So there's multiple ways to do it. Okay, so that's a couple examples of hands-on, how in like carpentry is a good example for geometry, just doing things around the house that involve areas and lengths and heights. You'll be surprised how much geometry could factor in, especially with right triangles. Okay, which we haven't got to yet. Example 9 is working with a circle, and we have to find the area and circumference of the circle, which has, as you can see, a radius of 5 centimeters. Well, recall that the area of a circle is pi r squared, and I've already plugged the number in, so it'll be area is pi times 5 squared, which is going to give you 25 times pi. Sometimes that's fine to leave it that way. If you want to, you can do that. In fact, on some of the WebAssign, they might want the answer with the pi, but then if you multiply by pi now, 3.14, let me look that up real quick, is 78.5 roughly cubic centimeters. So either answer would be acceptable. I haven't given you circumference, but the formula for circumference is either pi d or 2 pi times r. So if we go 2 pi times r, that'll be 2 times pi times 5 is 10 pi centimeters is your circumference. As a decimal form, the approximate, as they call it, is 31.4 centimeters. So if in a book or WebAssign, if they ask for exact, you want to enter the answer with pi. If the WebAssign or the book ask for approximate, they want the decimal form using 3.14 or 16 or whatever value you do for pi. Typically, there's one on your calculator built in. If you hit the pi button, that's probably the best option, and then you can just times by 25 or 10 or whatever. So that's an example of area of a circle. The next one is is kind of just a historical problem. It's the last problem in the notes, but it goes and refers to the Rhind Papyrus that was found by a British historian, Scottish actually, historian named Henry Rhind, and he found this document. I'll look it up. It's on my PowerPoint. He found it in Egypt, Luxor, in 1858. It's traced back to 1650 BC, so it's quite an old document. It's on the old papyrus plant when they used to make papyrus out of the plant, the paper, and kind of like a scroll, and it had all these problems in it, and I just took out one problem of it. It's kind of interesting. It says and if you want to Google this more, you can read more about it. There's some things. There's also a Moscow papyrus that kind of is traced back to the Egyptians, and it involves, I think, some mathematics as well. But anyway, it says a square of length 8 is the same as a circle of 9. So if we have a square that's 8 by 8, that is the same as a circle with a diameter of 9. Now, if you look at this, if we compare formulas, remember the area of a square is 8 times 8, length times width or side squared. And then if we take half, we got to find the radius here because the diameter is 9. Well, the radius would, if we stay with fractions, it'll be 9 over 2. So it would be pi times 9 over 2 squared. So if we square 8, 8 times 8 is 64. 9 halves squared is 81 over 4. So if we were to solve this for pi, pi would end up equaling 4 because I take the reciprocal and times by 64. So 8 over 81 times 4 over 81 times 64 would actually give you 256 over 81. So using that problem out of the Rhind Papyrus, we get that the Egyptians' kind of estimations of areas, that pi would be 256 over 81. If you actually do convert this on your calculator, it's pretty close. It actually comes out to 3.16. So they often, in some books, have called that the Egyptian value for pi. It really, in a sense, isn't. This is just doing a neat little trick with this problem, which is kind of cool to compare the areas and get an approximation for pi that's very close to the real value for pi. But the Egyptians didn't really have the idea of a formula, and they kind of just, I guess, estimated areas in their heads, if you can imagine. It was long before, Descartes came by, with the concept of formulas and stuff like that. So you're going back so far that the math was so primitive. We didn't have things such as algebra back then. So there really wasn't, substituting in a formula and figuring things out. So they just kind of estimated in their heads these examples, but they are kind of neat to look at. And as you can see, if we use the numbers here, it does come out pretty close to the actual value for pi. So that's just kind of a fun little example to finish up with, and it does review the area formulas. And I usually do this in class just to kind of, give students an idea for how far back does the idea of area go? Well, it goes back to at least 1650 BC. Of course, they thought about things a lot different back then than they do now, but it's kind of neat to see that. So that wraps up that unit. I will have several more units on Chapter 7 posted on the YouTube playlist. That's it for today.